you've already got my brain thinking already. So just to let you know, good presentation for everybody. But yeah, you got my brain thinking about some of these things, especially for how to adapt and to get things implemented and applying them. Back to you. Who's next, Mo?
Good conversation. Thanks a lot, Kiva. Good morning, everyone. As Kiva just mentioned, we switched our AWS team switched our focus to a coding challenge, and we started some infrastructure as a code effort in this sprint as the first step of the preparation. Per customer's requirement, we are going to rely on Jenkins to handle entire CI/CD workflow and the integration with security and quality control. We initialized the infrastructure design and figure out a list of appropriate tools to meet both customers' need and industry standard. Not only the application hosting infrastructure, but also the Jenkins pipeline itself is desired to be infrastructure as code. At the beginning of this sprint, we leverage AWS services such as Elastic Container Service, the Elastic Container Registry, the AWS Certificate Manager, the Private Certificate Authority, Amazon Route 53, AWS Code Pipeline, Code Commit, Code Build, and CDK to deploy the initial high available and fault-tolerant Jenkins controller and agent, and build out a CI/CD pipeline for deploying changes, not only the application changes, but also Jenkins infrastructure. We built custom Jenkins controller and agent images with necessary plugins and configurations, and push those custom images to our own repository with SSM parameter store protected. We also created a deployment role to allow Jenkins to deploy a CloudFormation stack to demonstrate cross-account deployment. This initial version, I would say, is very similar to the one Nick and team built previously in Azure. And after deep diving and meeting with our partners, we made the decision to switch our IAC approach from CloudFormation CDK to Terraform, which is, I would say, a big effort, especially for me, rookie in this Terraform world. To accommodate this change, Raza and I started building some basic blocks and rewrote the deployment configurations. During this process, we also added some cool features on top of the original design. As you can see here, this project is very cost sensitive. We provide like 2 capacity queues in our Fargate cluster. The always on Jenkins controller and some high priority task will go to this primary queue, while the lower priority task go to the spot queue instead to reduce the workload in the primary. When a code commit is detected, a container instance will be automatically provisioned, but only lasts until the build job completes. Therefore, we don't need to maintain any standby build agent, and everything is on demand. I'm proud to say the response time of this self-managed build queue is very close to native AWS code build or Azure DevOps. So hopefully, it can meet the future development work's need. Although the containers are up and down frequently, the build history and the logs need to stay permanently. So we introduced the AWS EFS as a storage and integrated it with the ECS as a mounted volume, and make each short-lived container stateful. And the EFS itself is serverless, it's easy to back up, and we can easily deploy across regions for disaster recovery as the project needs. I think that's pretty much everything I completed in this sprint. Does anyone have any question? Cool. If not, then I will pass it over to Josh to introduce the upgraded ingestion feature in our AWS chatbot. Thank you.
Thanks, Mo. So Mo and I have both been working on the Anika AWS chatbot. developing this bot that is hosted specifically on AWS services and utilizes some of the awesome AI features that Amazon has developed. This slide is actually from the last sprint.